This is going to be a really quick video about trigonometric differentiation. When we talk about trigonometric functions such as sine x, cosine x, tangent x, we know that they have their trigonometric derivatives. Proving those derivatives is kind of difficult and too long for a video, so I'm going to give you directly the table of trigonometric differentiation. For example, here we have the derivative of sine x is cosine x, derivative of cosine x is negative sine x, derivative of tangent x, secant x squared, derivative of secant x is secant x times tangent x, and then we have derivative of cosecant x is going to be equal to negative cosecant x times cotangent x. And finally, we have the derivative of cotangent x that is equal to negative cosecant x squared. Now, knowing that, we're going to practice some trigonometric differentiation. So we have f of x equals sine x cosine x. So now we know that we have to use product rule because this is the product of two factors. And now, as the product rule says, we're gonna take its derivative as we always do. So we're gonna have d over dx of sine x cosine x plus, I'm using this red color indicating the derivative, and as you know, product rule, first derivative times normal factor plus the normal factor times the second derivative. You just have to take the derivative of one and the other not, plus derivative of the other plus the factor you first took the derivative. So now, continuing, we have sine x times derivative of cosine x. So now, following this table over here, we know that derivative of sine x is going to be cosine x, so we're going to have cosine x. I should mark that in red, indicating that's the derivative. And then we have cosine x plus sine x times the derivative of cosine x, we know that is minus sine x. So we're going to have minus sine x. And this is the derivative of this one. So now we just have to multiply. Cosine x times cosine x is going to be cosine x squared. And we have a minus, so we're going to have minus sine x squared. Minus sine x squared. So that's the derivative. We know that f prime of x is going to be cosine x squared plus sine x squared. Now let's take another example. We have a function here, f of x, x squared, sine x. Now same process, we're gonna do product rule. So now we're gonna have d over dx of x squared times sine x plus x squared, and then d over dx of sine x. So now we know derivative of x squared is going to be 2x times sine x plus x squared times derivative of sine x. We know in our table, derivative sine x, cosine x. So we're going to have cosine x. So now we have 2x sine x plus x squared cosine x. And this is the derivative of this specific function. Now let's say we have another one here. We have f of x to be sine x over tangent x. Now we know we have a product rule, so let's apply our product rule. We have d over dx of sine x times tangent x minus sine x times derivative of tangent x, and then all of this divided by tangent x squared. And now we know that derivative of sine x is cosine x. I'm going to keep our colors constant. Cosine x times tangent x minus sine x, and then derivative of tangent x, we know thanks to our table, derivative tangent x secant x squared. So let's put secant x squared, secant x squared, then all of this over tangent x squared, and this is our derivative over here. So trigonometric differentiation follows a typical differentiation. When we talk about power rule, product rule, quotient rule, they all follow the same procedure. You just have to know their derivatives, because it's not the same thing as having, for example, derivative of x squared. We know that of the power rule is 2x. When we say derivative of sine x, we just have to remember this little table right here. Derivative sine x, cosine x, derivative cosine x minus sine x. We just have to remember this little table over here, and then apply our derivative rules and differentiation procedures.